Hello friends, welcome back to my channel Sulba Sutras Academy. My name is Sumit Mishra and I welcome you all. So our today's topic is polynomial. And in polynomial we are going to do exercise 2.1. Polynomial is actually exercise 2 from CBSE class 10 mathematics, and we are going to do today exercise 2.1. So before moving for solving exercise 2.1, let's understand what is polynomial. Okay, so a polynomial can be, so polynomial is also known as a function for x. So here I am telling you this polynomial is form x, that will be given as x plus 2 or px equals to x square plus 2x plus 3, px equals to x cube plus 3x square plus 4x plus 3. So you can see this all three is a polynomial. Okay, so this is polynomial, a linear polynomial. What does it mean? So first understand what is degree of polynomial. You might have heard about it, but I want to make you revise for it. What is degree of polynomial? So degree of polynomial is the highest power of x, or in which the function is been written. In this case, highest power of x, that will be the degree of polynomial. So see, in the case of first equation, you can clearly see that the maximum power for x is 1. So degree of the polynomial for 1 is, so for equation 1, degree is 1. Okay, for second, degree is 2, and for third, degree, because you see over here the highest power of x is 2 over here, so degree is 2 over here. And for third, you can see that the highest power of x is 3. Other than that, we have x square, so that is less than 3. Then x to the power 1, that is less than 3. So the highest power of x is 3. So degree is 3. Okay. So when a polynomial is having degree of 1, then such type of polynomial are called linear polynomial. What I told? So linear polynomial, the polynomials whose degree is 1. The polynomials having degree of 1 is known as linear polynomial. Understand? See the case of example 1, what I wrote over here, x plus px equals to x plus 2. So here degree is 1. So such type of polynomial is linear polynomial. Okay. Now what is quadratic polynomial? What is quadratic polynomial? So a quadratic polynomial is a polynomial having degree of 2. Having degree of 2. So quadratic polynomial are polynomials having degrees of 2. So such type of polynomial is quadratic polynomial. Okay. So the example 2 that I have wrote, px equals to x square plus 2x plus 3, this are the quadratic polynomial. Okay. Now what is cubic polynomial? What is cubic polynomial? So from naming you can easily understand, having degree 3. Polynomial having degree of 3 is known as cubic polynomial. Is known as cubic polynomial. Okay. So here see the example 3. So px equals to x cube plus 3x square plus 4x plus 3. So this is the third example, is having degree of 3. Hence these are cubic polynomial. This is the example for cubic polynomial. Okay. Okay. Now move on. The next thing I want to tell you is, this is done. So the next thing is, what we are going to learn is, what is the value of px at x equals to k, suppose, where k is any integer. Okay, what is the value? If someone will ask you, they will give you some polynomial px and they will ask you what is the value of px at x equals to k. So simply substitute, where k can be any integer. It can be minus infinity to plus infinity. So minus 30, minus 40, then in positive side it is 0, 30, 40, 50, anything you are putting it. So simply substitute x as k in the polynomial. Okay, so what does it mean? Let's understand with the example. Suppose we have px equals to x square plus 2x plus 3. Okay, now if someone is asking you what is the value of px, what is the value of px at x equals to 3. So what is the value of px at x? So simply put x equals to 3 in polynomial in equation 1. Substitute or put x equals to 3 in 1. So what you will get? P3 equals to, I am simply substituting x as 3. So P3 equals to 3 square plus 2 into 3 plus 3. Okay. So 3 square is 9 plus 2 into 3 is 6 plus 3. So 9 plus 6 is 15, 15 plus 3 is 18. So P3, the value of Px at x equals to 3 is 18. So the value of Px at x equals 3 is P3 and that value is 18. As simple as that. So you might be given some polynomials, and if someone is telling you to find the value of Px at some number, okay, that can be integer or that can be real number also. It doesn't matter. The solution can be anything, even integer or real number. It's not mandatory that it should be integer only. It can be real number also. Real number in some decimal form also. Like 2.3, what is the value of px? I can find it, right? P 2.3 equals to 2.3 whole square plus 2 into 2.3 plus 3. Okay, so get this value. That will be the value at x equals to 2.3 for px. Okay, now, so till now we have seen px. Now in some problem you might see as py. It doesn't matter. If someone is telling you, so px means simply the polynomial in the form of x. So polynomial in the form of x. So if you will see LHS, if it is polynomial of form x, then right hand side it will be some equation in the form for x. Now if the polynomial is given in y, doesn't matter. If the polynomial is given in the form of y, then you can see like this, y square plus 2y plus 3. As simple as that. It doesn't matter. So polynomial can be written in the form of x, y, z. It doesn't matter. Okay. So polynomial can be written in any form. So pm equals to m square plus 2m plus. That's a polynomial. Okay. So it's a polynomial. Okay. So it doesn't matter. For the example, if I have told you for x, that doesn't mean it cannot be. The polynomial cannot be in any other form. It can be in any form. It can be in x form, it can be y form, a, b, c to z, any form you can write the polynomial can be represented. Okay. But when we consider with our coordinate system, a two-dimensional coordinate system, then you can see that it is always of the form x and y only, because here the horizontal line is in x line and the vertical line is y line. So you will always see when we will consider our two-dimensional coordinate system, then the equation will be in the form of x and y only. Okay. This is very important thing, but the polynomial can be represented in any form, as simple as. But when we consider for our two-dimensional coordinate system, it will be in the form of x and y. Okay. Okay. Then let's move on. So what is zero of a polynomial? So in CBSE class 10, you will learn about zero of a polynomial. This zero in another books, if you will see, it is also known as root, the root of the equation. So don't get confused when you are doing in NCERT or CBSE books, you will read it as zero. In other books, you will see it as, if you are moving to some other state board books or ICSE and all, they might writing zero as root. So this is nothing but the root of the equation. Okay. So let's first understand what is zero of a polynomial. So suppose we have an equation called, suppose I am taking px equals to x square plus 2x plus 3. So what is the zero for this polynomial? So when we say let's find zero for a polynomial, that means what is the value for which the right hand side of this becomes 0? Okay, that is the zero. So find the values for which the right hand side becomes 0. What are the values of x for which this right hand side becomes 0? The value for it will be 0. So equate it with 0. So whatever value after solving, now we need to solve it. We need to solve this equation is x square plus 2x plus 3 equals to 0. If it is given like this, then you have to solve this equation to get the value for x. So I am not doing currently what is the value. We will see how to solve it. But understand, if we have any polynomial, it doesn't matter it's quadratic or cubic or linear also, it doesn't matter. So at what value the right hand side becomes 0? So at what value for x the right hand side becomes 0? Okay, that is the 0 of the polynomial. So here x equals to, suppose you got 2 and x equals to 3 you got. So this 2 and 3 is the 0 for polynomial. This is just a virtual thing I am telling you, I didn't solve it. So please don't consider this as a solution for this equation. I repeat, please don't take it as a solution for this. I simply told you an example. If suppose we, after solving, we are getting, suppose x equals to 2 and x equals to 3, then 2 and 3 is the 0 for this polynomial. Okay, so as simple as that. So similarly, if it is a linear equation, p equals to, suppose 2x plus 3, so at what value this right hand side becomes 0? Px equals to, we have this. So what is the 0 for this polynomial? If that is this, then simply equate the right hand side with 0 and get the value. Here we can simply do 2x. If you know basic algebra, we can solve it. So 2x equals to minus 3, x equals to minus 3 by 2. Okay. So this is the 0 for this polynomial, px equals to 2x plus 3. So simply equate the right hand side with 0, whatever form of p. It can be in x form, y form. As I have told you, polynomial can be given in the any form, pa, pb. So if it is given as pa, then the right hand side will have a power form for a only. Like if it is written as pa, that will be given as 2a square plus 3a plus 3. So in the form of a only. If I am telling you in the form of b, pb, so pb equals to, it will be some number into b cube plus, if I am talking about some cubic thing, so 2b cube plus 3b square. So all the power for x will be in the form of b only. So it doesn't matter, polynomial can be of any form, like pa, pb, pc, pd, dot dot dot, pz also. So it doesn't matter. So if you are solving that equation, just equate the right hand side with 0, solve the equation, and after solving, whatever values of x you are getting, that will be the 0 for the given polynomial. Okay, yeah. So generally for linear one, for linear polynomial, if it is written as px equals to ax plus b, then the 0 for this will be x equals to minus b by a. We can solve it. How? Let's do it. So ax plus b is 0, because to get the 0 for this polynomial, we have to equate the right hand side with 0 and get the value for x. So ax equals to minus b. Why? Because this is plus over here, when it is going to the right hand side of equals to, and the plus becomes minus, minus becomes plus, multiply becomes division, and division becomes multiplication. So here I am taking this plus thing, after plus, so plus b I am taking to the right hand side, so it becomes minus. Now you see over here, this a is multiplied to x. So when we take it to the right hand side of equals to, then it will be the division. So it is minus b by a. So the root for any linear polynomial can be given as the constant term. So these are the constant term, like it will be some integer, okay, like plus 2, minus 2, 0, it can be anything. So I mean anything means in the sense it is any integer. So plus 2, plus 3, plus, or even a real number also, not only integer, sorry for that, it can be in real number also. So these are the constant term. So constant in the sense it will never change. These are called variable. When we write a, b, c, d, so they are variable. Okay, and this, and if it is given as a number form, it can be real number, integer, or whatever. It's the constant term. Okay. Now I forgot to tell you one more thing, the coefficient. I told you about degree, but I didn't tell you about coefficient of some power things, of any power. So what is coefficient? We have heard about degree. So degree is the maximum power. What is the coefficient? So suppose we are taking some linear equation, px equals to 2x plus 3. So here the coefficient for x is 2. So 2 is the coefficient for x, and 3 is constant, of course. Similarly, if I am writing as a quadratic equation, then px equals to 2x square plus suppose 3x plus 5. So if I have been asked what is the coefficient of x square, or what is the coefficient of the highest degree of x, so in both cases the answer is 2. 2 is the coefficient of x square. 3 is the coefficient of x. What is getting multiplied with the things what I am talking, coefficient of x, coefficient of x square? What is the number that is getting multiplied of it? It can be 1, 2, 3, like that up to infinity. And this is again constant because there is no x thing attached with it. So the coefficient of x square is 2, coefficient of x is 3, and 5 is constant. Let's take example for some cubic equation, 2x cube plus 3x square plus 2x plus 5. So here the coefficient for x cube is 2, the coefficient for x square is 3, the coefficient for x is 2, and the coefficient for, the 5 is a constant. So this is the coefficient. So you understood degree and coefficient. This will be helpful for you when you are solving. Okay, now let's come back to the linear polynomial. So here the coefficient of x is a and b is the constant thing. So after solving, if you are finding 0, then of course right hand side we need to equate with 0, and after solving we are getting x equals to minus b by a. That means minus b is, so minus of constant term, so minus of constant divided by coefficient of x, correct? So this is for linear only, it's not for quadratic and cubic. So when you are finding 0, then the 0 for the linear equation can be found as x equals to minus of constant term divided by coefficient of x, as simple as that. Okay, so we have understood what is 0. So 0 is just the solution for which the right hand side of the given polynomial becomes 0. After solving, whatever values of x you are getting, that is the 0 for it. Now understand, that will be the 0 for the polynomial. Now understand the geometric form. So geometric form of 0, what does it mean? Geometric form. So when I will talk about geometric form, then of course it will be with our two-dimensional coordinate system. Okay. So hey, this is, here you will get the graph. Okay. So if it is given, so here it will be always in the form of y and x only. It cannot be in, I told you previously also, that whenever we are talking about the geometric form or in the coordinate system, our two-dimensional coordinate system, it will be always in the form of, the equation will be always in the form of y and x. Okay. So if suppose the first problem we wrote px equals to 2x plus 3. So in our coordinate system, in our 2D coordinates, the same thing can be written as y equals to 2x plus 3. Why? Because y is a function of 2x plus 3. Or if it is it can be like this also, x equals to 2y minus 3. So any form it can be represented. So you will not see for 2D system it is written as px equals to something. Of course there is no harm in writing, but it will be always in the form of y and x. Of course y can be left side, so y can be represented in the form of x, or x can be represented in the form of y. I have shown you two examples over here. So similarly for the quadratic system also and cubic system also. Now understand, if we have given graph, so I am not going to draw graph and all, we will do it whenever it is required, but understand the basic funda. If it is given in the form of y equals to suppose 2x plus 3, so if right hand side is of the form of x, then we need to see at how many point the given graph, if suppose this is a graph for us, of course this is not a graph for the given equation. What I am telling you is, if we have a graph like this and he is telling me that at what is the number of 0, by looking at the graph you find the number of 0. Okay, so just check if it is a form of x. So if it is y equals to something into x, some coefficient into x plus some constant, okay, or so take y equals to suppose ax plus b is there. Okay, so check it, this equation, if this is the form for suppose ax plus b, then check at how many point the given equation touches the x-axis. Okay, at how many point the given graph touches the x-axis. Okay, but if it is of opposite form, suppose x equals to ay plus b, then what we need to see, at how many point the given graph is touching the y-axis. Whichever is in the right side, that axis we need to see. So here in the first case, in the right hand side we have the form x, coefficient into x plus some constant. So for first part I will see at first equation, I will see at how many point the given graph touching the x-axis. So that many 0 will be there for the given equation. In the second case, since the right hand side is in y form, so in this case we will see at how many point the y-axis is getting touched at. Okay, suppose it is like this. So here you can see it is touching y-axis at 2 points. So number of 0 is 2. Similarly, if it is like this, so you can see it is touching x at 2 points. So this is of the x form and this is of the y form. Of course, this is a quadratic equation graph. We will see it in later on. So this thing is cutting at 2 points. So there are 2 zeros for it. Similarly, this is of y form, this is of x form, and this is of y form. So both the case you are saying it is touching at 2 points. Now let's understand one more thing. What is the maximum number? What is the maximum number of points that we can get for linear, quadratic and cubic expression? So what I am telling you is, let's go for linear polynomial first. Linear polynomial. So what is the maximum number of points a linear polynomial can touch x-axis or y-axis? That is 1. The maximum number is 1. Why? So it can be 0 or 1, nothing else. So the maximum number of 0 will be 1. As simple, 0 or root, both. The maximum number of 0 for a linear polynomial is 1. So it can have value 0 and 1. Take an example. Let's take an example, y equals to 2 and y equals to 2x plus 3. Okay, so we have two equations over here. We need to find at how many points this two equation is touching. So let's first go for the first equation, y equals to 2. So if you know how to draw the graph, then it's fine. If you don't know how to draw the graph, then let's see how to do that. So since you are saying y equals to some constant, okay, so of course this y value will be fixed, okay, it will never change for any value of x. If any equation you are seeing like this, then while taking point for the graph, you take any value of x, suppose -2, 0, 3. Okay, you put any value of x, the y value will remain constant, and that value is 2. If it is like this, if suppose y equals to 3 is there, then here this will be 3, 3, 3. Okay, so this is very important. For any value of x, y will remain constant. Now let's draw this in the graph. Let's draw it in the graph. So the first point we have, the coordinate system is like this, -2, 2. Okay, so x value is -2. So this is origin for us. So minus will be in the left hand side, -1, -2, correct? And positive thing will be in the right hand side, 0, 1, 2, 3. Okay. Now let's understand. So what is the first point we have? X is -2. So we will go in the left direction up to -2. So this is -2. Now go in the positive direction for y, 2 unit. So this is in the y direction 1 and y direction 2. This is y direction -1, y direction -2. Okay, now see. So first thing is, let's see first x. So -1, -2. So here is done. Now y is 2. So we need to go in the positive side. This is positive y, this is negative y. This is positive x, this is negative x. So you see over here, first thing is negative x. So we will go in the left hand side 2 unit. So that is -2. Now we have positive y of 2. So from -2 we will go 2 unit up. So this is our -2, 2. So this is -2, 2. Now second is 0, 2. So x is 0 and y is 2. So x is 0 is over here, origin. You see it, origin is 0. So x is 0, stop over here. Now y is 2 unit, and that is positive. So we will go from the 0 origin 2 unit up. So this point is my 0, 2. Okay. Now third point is 3, 2. So 3 is positive. So we need to go to the right hand side. So 1, 2, 3. So from 3, this is our point 3. And go now, x is done. Now y is 2 unit, and 2 unit is positive. So from 3 we will go 2 unit up. So this is our 3, 2. Now join this 3 point. So what you are seeing over here? So this is the straight line. Okay. So linear equation will always be a straight line. Okay. Now see this equation. This is not meeting at any point on the x-axis. Correct? This is our axis for x. It is not meeting at any point. The given straight line y equals to 2. This is y equals to 2. This straight line doesn't meet at any point on the x-axis. So in this case, our number of 0 is 0. Okay, very simple. So this is for y equals to 2. Now let's solve for y equals to 2x plus 3. Y equals to 2x plus 3. Okay, let's draw graph for y equals to 2x plus 3. Okay, this is x, this is y. So the first thing, let's put some negative number like -1. So if x is -1, so y will be equals to, so the value of y at x equals to -1 is 2 into -1 plus 3. So -2 plus 3, that is 1. Okay, so y value is 1. Now put x equals to 0. This I put x equals to -1. Now put x equals to 0. Now put x equals to 0. So what will happen? Y will be 2 into 0 plus 3. So anything multiply with 0 is 0 plus 3. That means 3. So at x equals to 0, I got y value as 3. Now take it again 1. For x equals to 1, what will happen? So at x equals to 1, y will be given as 2 into 1 plus 3. So 2 into 1 is 2 plus 3. That means 5. So this is 5. Okay. Now let's draw the graph. So if you'll see, this is origin. This is origin, this is negative -1. Okay, this is positive 1. I need 1 1 only. You can draw more also, it doesn't matter. Okay, but y maximum is 5, positive side. So positive side I have to go to at least 5. 1 2 3 4 5. So this is positive y, this is negative y, this is positive x, this is negative x. Okay. Now let's draw. So first point is -1, 1. Okay. So -1 will go in the left hand side because this is the minus x axis. So we need to go to left side. So this is -1. -1 and then y value is 1. So at -1 point we will go 1 unit up. So this is our point -1, 1. Now second point is 0, 3. So this is our origin 0. Okay. At 0 now y value is 3. So from 0 only we will go 3 unit up. So this is our point 0, 3. Okay. Now the third point is 1, 5. So at this is our 1, and at from 1 we will go 5 unit up. So this is our 1, 5. So if you will extend it like this, it will go. Okay. Now see this. It is meeting on the x-axis over here. Okay. So this equation has 1 0. Why? Because it is meeting at x-axis at one point. So there will be 1 0 for this equation. Okay. Similarly, for quadratic also, I am not going to draw for quadratic. Yes, we can draw, there is no harm in it. But first problem I have shown you just for understanding purpose how to draw the points and get the number of zero. How many number of zeros are there? So the for linear equation, it can be 0 or 1 zeros. Okay, that is the maximum number of 0 is 1. For quadratic equation, the maximum number of 0 is 2. Okay, it can be 0, 1 and 2. But the maximum number is 2. It cannot be more than 2. So whatever degree, can you see one thing? The degree for linear equation was 1. And the maximum value of 0 is also 1. For quadratic equation, the maximum degree was 2. Maximum number of 0 for quadratic equation is also 2. Okay, and for cubic, the maximum number of 0 will be 3. Maximum number of 0 is 3. That means it can have 0, 1, 2 or 3 zeros. Okay, the maximum number of zeros is 3. Similarly, if there is a polynomial of power n, so the rule says if the polynomial is having degree, the maximum degree, having degree as n, then number of 0, then maximum number, maximum not number of, but the maximum number of zeros it can have is n. Clear, right? So whatever the degree for the polynomial is, the maximum number of zeros for that polynomial will be the degree, will be equal to the degree of the polynomial. Okay, so this is very important thing. If you know up to this, then you will able to solve all the problems. Okay, so let's see, let's start doing the exercise. I hope you understood the basic concept. I know, I mean, drawing graphs and all were not required, but for your understanding purpose, I have shown you how to draw the graph, and I have shown you how for one equation number of 0 was 0, and for another equation it was 1. Similarly, for quadratic and cubic also it will be that at how many points the x-axis it is getting touch, that will be the number of 0, and for quadratic equation the maximum number of zeros will be 2. That is, it can have 0, 1, 2. Maximum means it can have 0, 1, 2, but not more than 2. Similarly, for cubic equation it will be the maximum number of 0 will be 3, and it can have a value, the zeros, the number of zeros can be, that is, the number of zeros can be 0, 1, 2 or 3. Okay, now let's move on to exercise 2.1. Exercise 2.1. So what is the thing over here? Okay, so here he is telling the graph of y equals to px. Simple, y equals to px. That is, it is of some polynomial, as simple as that. So px can be linear, quadratic or anything. So what it is telling it is of the form of x. The polynomial is of the form x, and y equals to the x form. Okay, for some polynomial px. So find the number of zeros of px in each case. So if you will see first problem, the graph is like this. Okay, so the graph is like this. This is origin, this is x, negative x is written as x dash, positive y is y, and negative y is written as y dash. Don't get confused, you can write plus x minus x also, but generally when you will see the graph, it is written as, for your understanding I have write it as plus x and minus x, but in the normal graph when you are solving for the exam purpose and all, this is represented, the negative is represented as a dash thing. So x dash and negative y is y dash. Okay. Now let's see over here. This is same as how we have done for y equals to 2, you remember? So this line doesn't meet at any point on the x-axis. You can see over here. It's not meeting. It's a parallel thing. Okay. Not even on infinity it is going to meet. Okay. It is not touching the x-axis. Okay. So since the given polynomial since the given polynomial okay doesn't meet the x-axis, okay, doesn't meet x-axis at any point, hence the number of zeros, okay, equals to 0. As simple as that. At how many point it will meet on the x-axis, that many number of zeros will be the solution for the polynomial. Okay. Now let's take example for the second graph. It is like this. It is like this. Okay. So you can see this. This graph is meeting at one point on the x-axis. True? So the given graph meets at one point on the x-axis. The given graph touches x-axis at one point, hence number of zeros equals to 1. As simple as that. Third question. You just need to see at how many points it is meeting at the x-axis. So third question is like this. Okay. So it is like this. So if you will see over here, then this graph is meeting at 1x point, 2x point, and 3x point. Correct? So it is touching this x-axis at 3 points. So it is touching this x-axis at 3 points. You see this? Okay? So the given graph touches x-axis at 3 points, or meeting also you can say, touches or meets x-axis at 3 points, hence number of zeros equals to 3. So for the given polynomial, the number of 0 will be 3. Okay, then next is, yeah, so next is fourth one is like this. Okay, x dash, y dash. Okay, so you can see this, the given graph touches the x-axis at 2 points, correct? The given graph or polynomial, you can say, the given graph touches x-axis at 2 points. Hence, number of 0 will be 2. Okay, this is very easy. So it is touching the x-axis at 2 points, hence number of 0 is 2. Next, fifth one. So fifth one is like this. So it is like a sinusoidal wave. Okay, so this graph is meeting at, just let's write x dash, y and y dash. So this graph is meeting the x-axis at 1, 2, 3, 4. You can see this, at 4 point it is meeting. So the given graph touches x-axis at 4 points. Hence the number of zeros will be equal to 4. Very simple. Then sixth one is x dash, y dash. Okay, so the equation, so the graph is like this, and then this. Okay, so if you will see over here, it is meeting the x-axis at 1, 2, 3. Okay, so it is meeting the x-axis at 3 points. So the given graph touches x-axis at 3 points. Hence the number of zeros will be 3. That's it. Okay, so our chapter got over here. The exercise 2.1 is finished. I hope you liked this video, and if you liked it, please don't forget to like and subscribe, and please share my video with your friends, with your near and dear ones who actually need it, who wants to learn something. Please share with them also. Okay, so here I am stopping this. We'll meet again in the next chapter, and for the same chapter, polynomial, in another exercise 2.2. Okay, so till then, Bye bye. Take care. And please come back again to see exercise 2.2. Okay. Thank you. Bye bye.